Hi, we are with Diego Jimenez from National Institute of Anthropology and History, Mexico. So hello,
Hello,
Diego,
how are
nice
you,
to have
George?
you here.
I'm very glad to be
Diego just gave a very interesting talk on some low-level features that can be extracted from 3D models of cultural objects and how they can be exploited in search engines and stuff like that on data management and all those issues regarding cultural management. So we're here just to discuss about your work and maybe explain in a few words what did you do, how did it went, what are the results?
Well, yeah, we are a group of researchers in Mexico trying to exploit the information related with shape. As you know, in archaeology, we actually use shape as an attribute that we can analyze to actually classify artifacts. That's one of the applications. The other one is to distinguish, obviously, one artifact from another. And so my research has to do with that. I mean, it's a group of people, archaeologists and also mathematicians and also computer scientists working together to try to find ways to explore and analyze the shape of archaeological artifacts in 3 dimensions. So that's the main concern of this research group.
So you actually do classification or something more like clustering? Do you know what you expect to come after the process of matching some objects, or it just pops up?
Well, the first thing we do is we are developing a search engine, which is the most basic function. We try to locate artifacts that are similar to a query model. So we have a database of 3D digital models, probably 1,000 models in the database. And when an archaeologist comes with a new artifacts and try to find similar objects, then we provide this search engine, something like Google. But instead of using words to search the database, we use the shape. And the second application is that we are trying to develop a new method to classify objects automatically, just by making the computers to look at the shape of the artifacts.
Okay.
So that's a second application.
Yes, great. So what is the method that you are using to actually digitize the objects in 3 dimensions?
Well, the digitation is using just laser scanning, conventional techniques of laser scanning. But the interesting part of our research is the development of some algorithms to describe shapes in a mathematical way. So we implemented some algorithms who have been proposed in the computer vision literature. Yes. Like there is one called harmonic functions. This is some proposal from a group in Princeton. But we also are developing our own algorithms, our own descriptors of shape. So that's let's say, the most difficult part of our research.
And do you believe that your methods of, trying to get some signature of the shape from the objects, so is it connected to the way that you digitize the objects? If I give you another 3D model that possibly has been produced by another method, do you believe that your methodologies are going to be efficient?
Yes, definitely. Let's say the analysis of shape is independent of the way that you digitize the artifact. So it doesn't matter through which method you actually produce a digital 3D model. The analysis of shape is independent to that, so you can use any method.
And what about scaling or maybe rotation?
No. Yeah, the good thing of our methodology is that you can analyze shape and it doesn't matter if your object is rotated in certain direction or another. So the method is invariant to scale and to rotation.
Oh, that's perfect.
So that is very difficult to achieve, but it's one of the things that we most do is that it doesn't matter the scale or the rotation. Is it
still under development? Have you already some evaluation results?
Well, we have the first prototype already working, but obviously we would like to make it even better because at the moment it analyzes the shape of artifacts globally. I mean, it's
yes.
analyzes artifacts that are complete. But as you well know, in archaeology, we
usually have
use
fragments.
Yes. So we are still trying to make the method work perfectly with fragments. Still, it works now, but not as efficiently as we would like. So it's still a development.
So do you see possibly an application in matching various fragments to build a whole object or something like that, to complete an object? Is it possible to apply such methods there?
Well, some of the methodology can be useful for that, but let's say to reconstruct artifacts is like another application.
Yes.
But it also has to do with analysis of shape,
Okay.
right? So it could be done, but it has to make some adjustments to the techniques that we are using now. Right now, we are only comparing the similarities of artifacts, yeah.
So it's more of a search engine.
Yeah,
of some sort.
Exactly.
Okay.
Yeah.
It was very, very
Yeah,
nice,
it's
the work
important.
that you
And
showed
the
us.
next step it could be to classify artifacts. Like we have a collection of 200 masks that they have different styles. So we would like that the computer recognition system and do the classification automatically without any input from the researchers, because that would be a great application for archaeologists.
Yes, yes. I have been working with them for a long time, and I know they are looking for tools like that.
Yeah. So our computer system is generic, so it can be applied to any collection. I mean, it can be a Greek collection or a Chinese collection, whatever it is.
It would be a great addition in a tool set for the archaeologists. So it was great having you here.
Thank you very much.
Diego.
Thank you, Josh.
Thank you.